Hi everyone, my name is Wadad and you're watching The Quantum. We're back with another video where we put the sick in physics. Today, we'll be exploring the physics behind archery. Now I won't be the one shooting the arrow. You know, my archery skills are so good, I didn't want to show them off on camera. But my friends from Smarter Every Day will instead be demonstrating an epic shot in slow motion. Now before we watch the video, what do you think will happen here?
I think they're going to stretch the string of the bow really fast. But a person with really long arms has to do that. Or magic.
Oh, how do you think they'll get the arrow to reach the target?
Well, I think you'd have to be strong enough to pull the arrow forward with the bow, and you'd have to aim it straight at the target.
Sai claims that he took one archery class 3 years ago and got 50 bullseyes. True story, he states, and he says he aimed it straight at the target. Besides magic, the consensus seems to be that a strong person, or someone with really long arms, has to stretch the string while aiming their arrow directly at the target. Now let's watch the clip and see if this is true.
Wasn't magic or someone with very long arms?
Oh, I was wrong. They did aim it slightly higher.
How on earth did that arrow land exactly on target if you aimed it higher?
Well, the arrow moves kind of like if you were to throw a football far away. You have to aim the arrow a little bit higher, just like you throw the football higher so that it reaches the target. When the archer releases the bowstring, the arrow plunges forward because the arrow is flung forward with a force of elastic, because the bowstring is elastic. This is the horizontal force. But a vertical force is also acting on it, and that's the force of gravity. It acts on it downward, pulls it towards the earth at 9.8 meters per second squared. These two forces combine, and this will cause the arrow to move in a curved path, called the projectile motion. We combine these two to get the total velocity at any given point in the trajectory, which is the path the projectile motion follows.
So you're telling me that we can figure out how high to aim the arrow? Well, why does that really matter? I feel like the higher I aim it, the more points I'll get.
Well, we talked about gravity's effect on the arrow, but let's take a look at Newton's first law. It tells us an object at rest will stay at rest, and an object at motion will stay at motion unless another force exerts on it. If you shoot this arrow super high, it's going to keep going and going and going, but gravity is pushing it down and down and down until eventually the arrow peaks at the top, and then gravity keeps pushing down and it reaches its target. This means the angle you aim it increases with the target distance, and it's necessary to compensate that for the effect of gravity on the arrow. So I ask you this, what do you think happens if we increase the mass of the bow? What about the arrow?
Well, I feel like it doesn't really matter. I mean, if the bow gets heavier, the gravity is the same and the overall speed of the arrow is the same as well. The only thing that happens if you increase the weight of the bow is that it's more tiring on the shoulders.
Well, not exactly. If the mass of the bow is heavier, the arrow is actually going to travel faster to the target. So let's say I'm standing here with a 25-pound bow and somebody behind me is standing with a 50-pound bow. Their trajectory is going to be about right here, where mine is going to go a little bit higher.
So based on what you explained, a heavier bow means a faster arrow, and then a lighter bow means a slower arrow?
Exactly. Another way to say this is that a slower arrow means the more time that gravity has to bring it down to the ground. So the trajectory of it is going to have to be higher than someone with a faster arrow or a heavier bow.
Whoa, I think this is better than magic.
But don't forget about inertia.
What's inertia?
What's inertia?
So, what's inertia?
Okay, so inertia refers to an object's tendency to stay at rest or stay moving. Increasing the bow's mass slows the movement in the archer's arm, not the arrow, while aiming, and this increases the archer's ability to aim more steadily at the target. And remember your prediction earlier?
About being super strong?
Yeah, while you're not pushing the arrow forward, you're not wrong about having to be strong enough. There's this thing called Hooke's law. It states that the draw weight is proportional to the draw length. So the greater amount that you pull back further in your draw length, the more you increase the force, that in turn increases the stored potential elastic energy. If you draw it back further, you're applying a bigger force, and the mass of the arrow isn't changing, which means acceleration has to get bigger to compensate for that, for the bigger force, because force is equal to mass times acceleration according to Newton's second law. And of course, there's a limit to how much your body can draw back and how much the bow can withstand before it breaks.
So you pull the arrow back on a bowstring and that's a force?
When the arrow is loaded on the bow, it's not going to go anywhere unless you apply that string force and launch it forward. Because, do you remember?
An object at rest stays at rest, and an object in motion stays in motion.
Unless acted on by an external force. Another object exerts a force on the arrow at the end. Do you know what it is?
The target?
The target.
The target?
Yes, the target stops the arrow according to Newton's third law of motion. For every action, there is an equal and opposite reaction.
But you mentioned energy earlier.
Yeah, there's also elastic potential energy. It's what you are building when you pull back on the bowstring. It comes from the stress in the bowstring and the limbs of the bow. The key word here is potential, because if you release the string without the arrow knocked on it, then the energy isn't converted into anything useful. It's going to be reabsorbed into your limbs and back into the bow. And this is called dry firing, which can easily damage the bow. But with an arrow knocked on the string, most of the stored energy is transferred to launching the arrow, that transfers from the bowstring to the arrow, giving the projectile its kinetic energy. As it gets to its maximum point, it turns into gravitational energy and back into kinetic energy until it reaches its target and stops. And then the energy is lost to its surroundings and the target. Keep in mind, some of the energy stays in the bow, and although bows are elastic, they're not 100% efficient, and energy is lost to thermal as well. Using the conservation of energy, where the total energy of a system stays constant from the potential energy through to the kinetic energy, we can calculate how far the bowstring must be pulled back in order to have the arrow reach a maximum height or a certain height. Now I'm going to play the video in slow motion, and I want them to focus on how the arrow moves.
It's shaking left and right.
I noticed it vibrated. I think the string makes the arrow move, but I'm not sure how everything that you're saying is actually true. I mean, the arrow did hit its target, but it moved to the side.
Well, this is actually a problem that archers have to get around. It's called the archer's paradox. And so basically, when you move your hand along the string, you're actually shifting the string a little bit. And this is because the force of friction is insufficient enough to stop the string from moving. This excites a mode of oscillation. So let's picture this as the arrow. Once the string shifts forward, the arrow is going to shift and it's going to go back and forth like this at two nodes right here. And once it leaves the bow, it's about completed one full oscillation. And it's going to keep completing these oscillations until it reaches its target.
How do we stop the arrow from bending?
Well, the stiffness of the arrow is its ability to bend. This is known as the spine. That's its resistance to bending. The more rigid the arrow is, the higher the frequency of oscillation. And so archers, they have to match this rigidness, the spine, to how far they pull back, the length, and their archering technique.
That's awesome. Thank you so much for teaching me. Who'd you learn all this from?
The one and only Mr. Mills.
Wow, guess I should learn from him as well.
You sure do. Overall, behind every talented archer is a physicist. As you can see, there are many factors that play a role in how archery does what it does. How some archers can complete the coolest of trick shots, and others may miss some just by having a flaw in their type of arrow or the calculation of the trajectory. But of course, the people in this video learned that all arrows have this projectile motion caused by a force. It turns its potential elastic energy into kinetic and gravitational energy, and of course, hits bullseye. Like always, if this video didn't inspire all of you to become future physicists, I don't know what will. Take a look in the description down below for a more detailed overview of today's lesson, inspired by Veritasium. And honestly, after all this work and summer right around the corner, I think I'm gaining the energy, get it, to explain how swimming works in the next video. Stay tuned and we'll see you next time, only at the Quantum.